Hello and welcome everyone to part 2 of our Organic Acids webinar series, with today's focus being on detoxification. I'm Phoebe, the Technical Manager at NutriSearch, and it's my pleasure to introduce our presenter again today, Dr. Dan Kalish, who many of you will know of as he is an internationally recognised speaker, consultant and educator on the topic of integrative medicine. Dr. Dan Kalish is the founder of the Kalish Institute, which is an online training program established in 2006, dedicated to building functional medicine practices. He leads functional medicine mentorship courses, teaching clinical application and patient communication through a very hands-on approach. In 2017, Dr. Kalish became lead faculty for the Institute for Functional Medicine Practice program, and he has authored 3 books on the subject and is a notable speaker at global integrative medicine conferences. So we do feel very privileged to have you, Dr. Kalish, presenting for us again today, and we look forward to the wealth of knowledge that you'll share. The presentation will be followed by a live Q&A session, so hold your questions to the end. To reduce feedback noise, you will all be in listen-only mode, so please type any questions you have in the Q&A box at the bottom of your screens, not the chat box, and Dr. Kalish will respond to these at the end. If you're listening to the recording of this, please note, rather than use the Q&A box, just send any questions to myself at techsupport@nutrisearch.co.nz and I'll forward them on. So without further ado, I'll hand over to Dr. Kalish. Thank you.
All right, thanks for having me. So we are going to talk today about detoxification and try to talk about it in a different way, Meaning that, there's some things that we all kind of know that are basic about this. I want to hit on some of the points that you may not know well. And then also, because we got so many logistical questions last time, we're going to take a few minutes and go over an ion panel and actually explain what all those reference ranges actually mean and how they actually work, because that is a bit of a mystery to all of us, isn't it? And pretty hard to interpret the lab if you don't understand what the reference ranges are. And yet, that's kind of the place we all find ourselves. And also, just so you know, we're offering for this audience half off, 50% off our Neurotransmitter and Mitochondrial Masterclass. So if you're interested in learning more about this kind of work, you can, I'm sure we'll send out some emails or give you these links, but you can sign up for these master classes and only pay half the price, okay? And that one is on neurotransmitters and mitochondria. Talk about neurotransmitters in terms of the stress-related markers and inflammatory-related markers to do with the brain. And then I get into some basic information on how mitochondrial function works and how you can interpret those labs. A little bit different than what we're talking about today. So I think one of the key points I always want to think about is that we need a treatment model. And functional medicine, by its very nature, is very amorphous, and everything causes everything, and it's very difficult for people to put together a model. And so I'm always interested in models because I don't think we can really move forward unless you have a clear picture of what you're doing. And I've divided this up into 4 categories. You can make your own model in any way that you want, but you have to have a model. If you don't have a model, then it's really difficult to understand what you're actually doing. And in my model, we go all the way from finding the underlying cause of the problem to treating symptoms and being able to excel at understanding each step of this so that you can find and treat the underlying cause while you suppress symptoms. And you're able to do both these things, or all 4 of these things, simultaneously. That's really like the ultimate goal that we have in mind in terms of being able to accurately help with a patient case, and then also a system, or I have this treatment map. We have 3 systems: neuroendocrine, GI. Today we're talking about detox. I put the detox system last because it's the most important, and usually it's the one you want to do last. Once a person's corrected their neuroendocrine and GI processes, you can start to segue over and move to treating the detox systems. So standard treatment sequence, again, we start with neuroendocrine, fix all that, get the GI tract working, and then work on detoxification as the final step, okay? If you start with detoxification, it's very easy for things to go wrong. And it can happen quickly and it can be a problem, And so when we're talking about detox specifically, I want to think about for today how to read these labs, both organic acids and amino acids in particular. A few other markers we'll throw in there. I want you to be able to learn how to identify heavy metal and chemical toxicity problems. as they appear on the test and to be able to differentiate between those. How to master the interpretation of the lab results. This is very important, related to ammonia toxicity. Whew, that's a hard one, a common one, and one you should know a lot about. If you haven't been doing programs to detoxify a patient's ammonia, then you're really missing out on one of the more important things. And honestly, I mean, I was in practice for over 20 years before I figured that one out. So I'll bet a lot of you are in that position as well right now. Just want to change that today. And then some of the basics that you already know about glutathione, but we can maybe get into the testing so you can see how you can measure glutathione levels quite effectively. And then a little bit on phase 1 and phase 2, which I'm sure you're all familiar with. I'm not going to spend too much time on the easy things, okay? And then how you can really, use these test results to sort through all these things. So we're talking about categories of toxins, environmental toxins, pesticides, this idea of total body burden. I think we've all kind of accepted that the world is toxic, right? And that this is, what our patients are suffering from. And one of the bigger problems really is the lipophilic, right? Or fat-loving toxins. The water soluble toxins, you just get someone to hydrate, right? You get them to drink adequate amounts of water, avoid the toxin, and then it gets out of their system. So what we're almost exclusively talking about are fat-soluble toxins that are locked into the fat tissue, that are going to stay in the fat tissue for a long period of time, for lifetimes, really. And where is all this fat tissue? Well, hopefully not too much of it is, on your butt or in your belly or something, but there's a fair amount of fat tissue in the brain. 60% of your brain is made out of fat. So we really want to make sure that we can protect the brain by reducing the toxic load of fat-soluble toxins. And in particular, when you think about this with the brain, because that's the easiest example to kind of imagine. So you have a chemical or a heavy metal that enters into the body. It could be that you're innocently breathing and you inhale something, or that you're using a medication, that you're you walk into a shop and there's something off-gassing. I mean, sometimes it's kind of obvious. Like I have a patient right now who smokes cigarettes. It's kind of obvious where his toxins are coming from. Oh, and then I had someone yesterday with a tooth problem. So a lot of people have, mercury fillings in their mouth. So there's a lot of different ways that toxins can enter the body. And at least in the studies they do in the United States, every single American has somewhere between like 122 and 700 toxins, many of which are neurotoxins, meaning they get into the brain. So this is a problem with all the patients that we work with. It's just a matter of how their body's adapted to, or how good they are at flushing out toxins. So when these neurotoxins get into the body, they hit up against the neurons themselves. That changes the functioning of the neurons, right? And these structures called reuptake ports are going to close or change, and that's going to shift the way that the chemicals in the brain are produced, serotonin and dopamine. There's also going to be damage to the neuron, and the end result of that is that you have a problem with the brain, broken brain. And so we want to make sure that we're clearing out these toxins, and you think about the types of symptoms that they can cause. Oh gosh, it ranges anywhere from waking up in the morning feeling horrible because the person was detoxing all night, to skin problems, to obviously things like depression, anxiety, and fatigue, infertility. I mean, the list goes on, right? And one of the problems, again, with functional medicine is that, let me go back a few slides here, is that, we're looking at symptoms like weight gain, fatigue, depression, anxiety, sex hormone imbalances, low sex drive, infertility, pain, allergies, ADD, ADHD, insomnia, brain fog. Every single one of those symptoms I just listed off could easily be happening because the patient's toxic with heavy metals or chemicals. Problem is, each one of those symptoms could also be happening because they have a GI infection, right? And that's one of the issues here. But if you have a systematic model and you're treating each body system with who? With every patient, right? You're testing and correcting every body system with every patient, then you're going to catch all these things. And where I see the biggest problems with patient workups is, let's say the patient has fatigue, depression, and anxiety. That's their main problem. And they have no digestive symptoms at all. So you ignore the GI tract and you skip that test and you go after something else. You know, that may or may not work, right? Because you can have a GI infection without any GI symptoms. Now with toxins, it's even more complicated because people who are toxic with heavy metals or chemicals, most of the time their symptoms are really non-specific. So it's very difficult to say, except for maybe like a skin problem. There's a few things that are kind of obviously toxin related, but most of the time the symptoms of what we're talking about are so vague that you can't declare that you have a toxin problem and I want to check your detox pathways because of the symptoms. So what does that mean? That means you have to test everybody for these. And as I mentioned, everybody in the United States, according to the CDC, has at least 100 toxins in their body right now. So this is every single one of your patients has this problem. It's just a matter of how are they adapting to it, and what are you going to do to try to flush these toxins out, you know. So there's the 2 liver detox pathways. So we'll start with the basics, talk about phase 1, phase 2. Then I want to get into a little bit more on oxidative stress, methylation, and we'll talk a little bit about the urea cycle in a minute too, okay? So the basics, phase 1, phase 2. Phase 1 run by B vitamins, antioxidants, etc. Phase 2 controlled primarily by the sulfur amino acids, glycine, taurine, glutamine, cysteine. This is pretty much what they look like here. And let me see here. These slides are a little weird. There we go. This is pretty much what the pathways look like here. So again, phase 1, cytochrome P450 enzymes. Phase 2, the conjugation pathways. And let's blow this up really big so you can see. And you imagine here's your poor liver just working along, you know, trying to do these things in a rather unfriendly world. So the nutrients used for phase 1, vitamin B2, vitamin B3, folic acid, that should be folate, it's an old slide, sorry, vitamin B12, glutathione, flavonoids, phospholipids, right? Basically, B vitamins and antioxidants are essential. So if you give somebody B vitamins and antioxidants, you're going to, by definition, speed up their phase 1. Now, sometimes that's a really good idea. Sometimes that's a really bad idea. Let's talk about that. So let's scoot over here for a second and look at phase 2. Again, let's zoom in a little bit on phase 2 here. You can see it better. Phase 2. What is phase 2 run by? The sulfur amino acids, glycine, taurine, glutamine, N-acetylcysteine, cysteine, and methionine. And what are the reactions? They have these fancy names: sulfation, glucuronidation, glutathione conjugation. That part doesn't matter so much. The point is that what your body's trying to do here is take a toxin that's bad, run it through phase 1 into some intermediary, then it's grabbed by phase 2, and then it's dumped out through the stool, through the sweat, through the urine. So what you don't want to do is speed up phase 1 with B vitamins and antioxidants and create all these intermediaries in a patient whose phase 2 is shut down, because then what happens is those intermediaries can have even more of a deleterious effect than the original toxin. So here's the original toxin. You give the patient B vitamins or antioxidants. They break down those toxins into intermediates, but phase 2 is not working. Phase 2 is broken. So I think of it, this is kind of a silly example, but it's like a washer and dryer, like you're washing your clothes. So if you wash your clothes in the washer and then you put them in the dryer, everybody's happy, right? You get fluffy, nice clothes at the end of this process. And they're clean too, right? You don't have to do anything. They're clean, just hit a button. Phase 1 is the washer, phase 2 is the dryer. Have you ever washed your clothes? And I did this recently. Washed your clothes and then you left your house for a few days and you forgot, you know, to put them in the dryer, and you come back, not a good thing, right? Because they're all moldy and it's really disgusting. So if phase 1 is working, but phase 2 is not working, if you're washing clothes and not putting them in the dryer, it's not a good thing. So that's how I explain this to patients. So if you're breaking this this phase 1 toxin down into an intermediary and it's not going through phase 2, it's going to make the person worse. You're pulling that toxin out of storage and just releasing it upon the body, and that's a bad thing. So be careful. If you give someone B vitamins or antioxidants, you could make them worse if their phase 2 isn't working. How do we avoid that? We simply measure phase 1 and phase 2. And that's why once in a while you'll see a research study that says, oh, we gave all these people antioxidants and they got cancer more often or got sicker or whatever. Well, yeah, if you don't do the testing, you can make somebody worse. One thing my teacher, Dr. Lord, mentioned the other day, and I don't know, the way he said it just sunk into my head. He's like, because I was going to prescribe vitamin A to someone, and he's like, Dan, any nutrient can be a toxicant. That's a direct quote from Dr. Richard Lord, the man that developed the ion panel. Any nutrient can be a toxicant. You give vitamin A at the wrong time, you can make the person worse. That's why we do the labs, to try to avoid those kinds of problems. All right, so phase 1 and phase 2 detox. Toxins cause all kinds of problems, right? Weight gain, fatigue. Toxins prevent fat burning. Toxins damage mitochondria. Toxins do just everything imaginable bad. So again, it's vague when you're talking with a patient about whether they're toxic or not, or it's vague whether their symptoms are being caused by toxicity or not. You know, it's hard to tell just from talking to somebody. That's why we do the labs. Now, when you're looking at organic acids specifically, there's a whole bunch of things that show up here. Arginine, N-acetylcysteine, methionine, glycine, magnesium, and antioxidants. Deficiencies in these markers indicate phase 1 or phase 2 problems. So let me just show you real quick a lab, and we'll cut back and forth. Let's start off to just keep it simple with just the organic acids part. So you can see all those different markers here. And, you know, I still have the great fortune every week of working with Dr. Lord. He's a scientist that developed this test. He was the first person in the world to run organic acids for integrative medicine. He got his PhD from the University of Texas at Austin in the 1960s, early 1970s. And he's really the founder, to a large extent, for the lab work that we do in functional medicine to this day. Okay. And he and I, actually, we just spent about 3 hours on the phone this morning talking, and he was teaching me about, what was he teaching me about today? Oh, cholesterol. Well, that's not really about today's topic, but anyways, so let's go through quickly an organic acids profile, and we'll come back to these when we do case studies. But I just want to show you all the things that you can learn about. So when your liver needs to make energy to clear toxins, that energy is going to come from ATP. So it's essential that the mitochondria are working properly. Okay, it's essential that the mitochondria are working properly. If you're back to our washer and dryer example, imagine that you unplug the washer and the dryer from the wall and there is no power. Not going to work, right? So phase 1 and phase 2 nutrients, as fancy as you want to get with those, will be completely ineffective if there's not enough ATP or cellular energy to run these detox pathways. So you just always keep your eyes out on energy production when you think about this. And again, here's our B vitamin markers. We talked about how important they are for phase 1, right? If these are high, person needs B vitamins. And but remember, be careful. Don't give too many B vitamins too early, because you can mess them up. You can also see these neuroinflammatory markers. That's not really what we're talking about now. Antioxidants, oxidative damage, and antioxidant markers. Those are important for, again, phase 1. To a certain extent, maybe for phase 2 also. And then you have the section that's explicitly on detoxification right here. And this is a little confusing because each one of these means something different. So let's look at these for a second while we're thinking about it, okay? Let's start at the bottom and work our way up. So sulfate is the single most important marker on this entire series of tests, according to Dr. Lord, who's a scientist that developed this test. If sulfate is out of balance, especially if it's low, then you have what we would call a collapse of glutathione. And that's going to imply that heavy metals or chemicals can build up in the tissue and cause a lot of problems. So sulfate is a very important marker for glutathione. Now, this is kind of easy if we go backwards here, because alpha hydroxybutyrate and pyroglutamate are also markers for glutathione. So there's 3 markers for glutathione here. Any one of these that are abnormal means that a person has a problem with glutathione. That's how important glutathione is. There's 3 different ways that we measure it. So, and this is a I'm just going to jump in. I'm going to take a drink here. This is actually water, but we could probably use a sip of beer right now, because what I'm about to explain is complicated. So you want to take, at least just take a deep breath. Okay, you ready for this? So now, if sulfate is low, it's bad. That means that glutathione is not in a good place. If pyroglutamate is low, it's bad. It means that glutathione is not in a good place. Here's where it gets complicated. Take a deep breath. If alpha hydroxybutyrate is undetected, you see that DL underneath detect limit? That's not bad. Okay, I know this is confusing. That's why we're all taking a deep breath now. So let me say that again. Pyroglutamate low is bad, you need glutathione. Sulfate low is bad, you need glutathione. Alpha hydroxybutyrate low, not bad. I'll explain why in a minute, okay? Let's look at the highs here. High alpha hydroxybutyrate, that's bad. High pyroglutamate, that's bad. You ready for this? Take a deep breath. High sulfate, not bad. Well, it's not that bad. It's a little bad, but not that bad. I know this is confusing. This is why I have a job. This is why you guys should take my classes, because this is confusing, all right? And if you get this wrong, you're going to do the wrong thing. So let me try to explain some of why this is even happening. So look very carefully now. Get out your glasses if you need glasses, and look at alpha hydroxybutyrate, okay? And then get out your glasses and look at sulfate. So if you look at sulfate, you see how there are these hash marks here? They're quintile markings. And then look at the reference range over here. It's 690 to 2988. So imagine that you're a scientist like Dr. Lord, and you're sitting at your LCMS machine and you're measuring stuff, and you see this spike that's somewhere between 700 and 2000. It's this huge spike. You can't miss it. It's very easy to see because there's just so much of this being thrown off, right? It's a high number. So it's easy to see it. So it's easy for them to differentiate by these quintiles. So it's a very accurate test because it's such an easy thing to measure because there's so much of it. So again, and the sulfate is low, that's the worst thing that can happen. If it's high, it's not a good thing. It means that their liver is burning through glutathione, but it hasn't burned out yet. It means the liver is working very hard with glutathione, but they still have the glutathione. That's why it's sort of a good and bad thing. Okay? Now look at alpha hydroxybutyrate. What's the range there? 0.9. That's the 95% reference range. That's tiny, that's less than 1, right? So when this thing makes a spike on the LCMS, GMS machine, whatever it's called, right? It's a tiny spike. It's really hard to see it. So guess what happens? You see the hash marks here? See how the hash marks are so wide? See that massive area there? That's an unknown zone. They can't find it in there. It's too hard to measure. They can't see it. Why? It's tiny little thing. It's just throwing off a tiny little spike. Okay, so with alpha hydroxybutyrate, it's almost always going to be undetectable. Is that bad? No, but the reference rate, you see how this quintile marking here, it's not a quintile marking, right? It's just only 2 of these. It's just, it shows you this whole zone in here, they can't tell where it is. So who knows? If it's undetected, it could be here, it could be here, it could be here, you can't tell. And why? Because it's tiny amount. You see that? Again, sulfur, you get thousands of units of sulfur or sulfate, you can see. 0.9 is where the hydroxybutyrate maxes out. So this is not a very accurate test in the lower ranges. They can only tell that it's a problem when it's high. So again, you see these lack of hash marks here is telling you we have no clue where it is. So if we say it's undetectable, it could be right here, or it could be right here. We can't tell. Why can't we tell? Because you can't see the thing on the machine. It's such a small little spike that's being thrown off. But still, it's important because if it's high, we'll catch it if it's high. That's what they're saying, right? So it's still important. So again, alpha hydroxybutyrate, does it matter if it's undetected? No, because it's hard to find. Why? Because this number is so small. It's a tiny little spike on this LCMS graph, okay? Sulfate, if it's low, it's really bad. It's easy to see sulfate. If it's high, it's a mediocre bad, but not horrible. Okay. I hope that wasn't too confusing. You might have to listen to this. Fortunately, we're taping it. You can listen to this again, okay? Because this is worth figuring out because assessing glutathione status is one of the single most important things you can do for any patient. Diabetes, cardiovascular disease, cancer, detox programs, anything, right? This is a very important thing to understand the nuances of these three markers. Now, glucarate is phase 1, phase 2. It's only bad if it's high. Orotate is for ammonia detox, ammonia toxicity, I should say. It's only bad if it's high, for the most part. And then 2-methylhyperate is a marker for xylene, and it's only bad if it's high. So those are easier, okay, to figure out and differentiate. I hope I didn't confuse you there. If I confused you, I was going to say you can raise your hand, but I won't be able to see it because we're online. If I confuse you, you can ask questions or just, let's see, let's go back to our regular scheduled program here. So that's like a little brief intro on detox markers for organic acids. Oxidation, super important. We're worried about the stress of the mitochondria. Not going to talk about that too much, but oxidative stress obviously is super important, right? I think you guys are all aware of that. And, my experience with the New Zealand talks in the past was that you guys are all pretty educated, and I don't have to like bother with the easier slides, and we can do more complicated stuff. And you all know what methylation is. A lot of the doctors in the United States have never heard these terms before, so I put these slides in. But you guys seem to be much more on top of it with your education on nutrition already. So let's just skip to the parts that you may not know. Okay, so when we're looking at, we're going to look at this in a moment, at amino acid levels. This is just kind of like a fascinating little fact, but it matters a lot, like more than one could imagine. It's probably the most important thing I've learned, at least in the last 5 or 10 years. This is a chart that shows human protein amino acid composition. I think it's the same chart for all mammals. I think it's even the same for birds and lizards and animals like that. Anyways, this is not just for human beings. This is human, life on this planet. I don't think it's the same for trees and stuff like that. But, for, let's just say mammals all have these same amino acids. And you're familiar with that, right? But guess what? We have these same essential amino acids in the same proportions in all of the different proteins that we produce. So let that sink in for a second. Every single protein that your body makes, and we're about to start to talk about proteins and how they relate to detox. Every single protein that your body makes has this same ratio of amino acids. If you'd asked me a couple years ago, I would have said, no way, like a bone protein that makes up your bone matrix is going to have different amino acid compositions than a heart protein. But that's not true. Right? Non-membrane proteins all have about this exact same ratio of amino acids. That's wild, right? So there's some really important clinical ramifications of this little fact. You need each one of these amino acids to make every single protein in your body except for collagen. Collagen's an exception. Collagen just needs a few little things. But forget about collagen for a minute. Every other protein in your body, every enzyme, everything that you make has to have these amino acids in this ratio. And look what's at the very bottom here is tryptophan. Tiny, tiny amount of tryptophan. And the most abundant is methionine. It's a little strange, right? If you're missing leucine, if you don't have enough leucine in your body, you cannot assemble any protein in the human body. It's not an optional thing. Okay, so when we're thinking about detoxification, we're thinking about building things, repairing things like enzymes that run your detox pathways and like mitochondria. And it requires a balance of all the essential amino acids to do that. There's no exception to that possible. Now, one of the kind of corollaries of that is that there's some, well, let me try to back up and say it this way. This is such a hard concept to understand, and everyone learns this wrong. I learned this wrong, and I want to try to teach it in a way that's different. When you think of an amino acid, like tryptophan is probably the best example. If I could see you guys right now, and I said, okay, put up your hand and tell me when I say tryptophan, what do you think about? Somebody in the front row with glasses on that looks kind of smart would put their hand up and say serotonin, and I would go, right, that's a good answer, you know, and then, but no, that's not the answer. So if I actually ask the question carefully, if I said, what's the most important thing that tryptophan does in the human body? And that kind of smart person, they always sit in the front row. I don't know why. The smart person in the front row would put their hand up, and they're wearing glasses, and they would say tryptophan is most important because it helps make serotonin. And I would say wrong. That's one of the least important things about tryptophan. And then I would ask the question again, and no one would ever get this right because no one's ever taught this. The reason why tryptophan is so important is because it's a rate limiting step, look at these numbers here, in the synthesis of all proteins in the human body. Tryptophan is a rate limiting step in the synthesis of all proteins in the human body. Why? Because it appears in all proteins in the smallest percentage. You can live without serotonin. Plenty of people are depressed and are still alive. You will not make it through the next 2 or 3 seconds without tryptophan producing enzymes for your body. Okay, you would just completely fall apart instantly. So tryptophan's main role is as an essential amino acid that helps with the assembly of all proteins in the human body except for collagen. Now, we learned, all of us learned, including myself, that tryptophan is most important for serotonin production because nobody ever taught us proteomics. Nobody ever taught us how proteins are made and folded, and we're always focused on specific conditions like serotonin is low, you're depressed, I'm gonna give you tryptophan. Now, we're about to talk about another one of these, that's why I'm bringing this up. Arginine is an amino acid that's required for making all your proteins, okay? But arginine is also the main nutrient that's used for ammonia detoxification. So when you're thinking about amino acids, you can think about them in 2 ways. They have a specific role, like in this case, getting rid of ammonia. That's what arginine does. Very important for your brain and for detoxing. Here we got tryptophan, has a role helping with serotonin and melatonin and helping with depression and insomnia. But you also want to think of these amino acids and all of them, and we'll see this on the labs in a minute, as essential for the production of all proteins. In fact, look at the header here. Symptoms associated with impairment of non-protein functions of amino acids. Non-protein functions of amino acids. Non-protein functions of amino acids. Okay. And then let me just show you one more thing about this. I have an image of it here. Here we go. Here's a protein. This is what they actually look like. They're beautiful. So here's an example of a protein. And you can see the amino acids here, right? And they string together, your body strings together all these amino acids, and then they go from being a sort of a string, you know, and then they start to fold and they create these helixes and these ribbons and stuff. They're really quite beautiful structures. And if even one of these amino acids is out of order, then this protein is going to misfold. This protein's not going to fold right. So you have this long string. You got like 600 amino acids all strung together. If alanine is in place of arginine, if one of them is in the wrong place, it's going to fold differently because that alanine is sticking out, right? And it has a little charge on it, electrical charge. And it's the way that these proteins fold is based on the charges of the amino acids in the string. And if there's a little bit off, it's going to misfold. And what do we call that? What do we call a misfolded protein that has one amino acid that's out? That's what we call a SNP. Okay, so why does it matter that you have these amino acids in sequences? What happens if one of those amino acids gets off a little bit, is in the wrong place? The protein's not going to fold right, and then that enzyme is not going to work right. That protein's not going to have its normal functions. So this is a particular importance when we're looking at detoxification, because a lot of people have genetic defects that cause problems with detoxification. Super common problem. And we see this in practice all the time. Here, I'm going to shift views here for a second, just because I can blow these up easier. Here we go. There we go. So now this is what's called the urea cycle. This is how we get rid of ammonia. And if you have not treated patients for ammonia toxicity, you're in for a treat. Probably, a year from now, you probably think, well, this is probably the most important thing this guy talked about. So why do ammonia problems happen? Well, it's right back to what I was just talking about, because of enzyme deficiencies. Actually, let me try this. My computer's kind of displaying weird today. Let me try this in a different way here, see if this works better. There, that might be better. Okay, you see these enzymes at the bottom, and they have names like you can barely even pronounce them, like enzyme 1, carbamylophosphate synthase, ornithine transcarbamylase, blah, blah, whatever. We can just call them by their number. So there's 6 different enzymes here that help run the urea cycle. And what are these enzymes? They're proteins. They're proteins. Could you have a misfolded enzyme that has to do with the urea cycle? Absolutely. There's 6 different ones that could get messed up. So there's, guess what? A high number of genetic defects with the urea cycle because there's all these different enzymes that can get messed up. And the odds on someone having an enzyme defect with one enzyme are bad, but 2 enzymes is more, right? And there's 6 different enzymes, any one of which can have a defect in them. So it's common to see urea cycle defects because of that. And what does it really mean? It means that the proteins that we just look like are not folded right. Okay, and what's the net effect of that is that ammonia builds up in the brain because you're not clearing it effectively. And that is a bad thing. And the amino acids involved, arginine, ornithine, citrulline, aspartic acid, etc. So we'll look at this in a minute. And if you have a defect with one of these enzymes, then you're going to have a buildup of a buildup in a deficiency. Like, for example, if this enzyme right here is broken, okay, then you're going to have a buildup over here and a deficiency over here. Similarly, if this enzyme is broken, then this is going to build up and this will be deficient. You'll be able to see this in the labs in a minute. You can actually see the genetic defects just kind of leaping out at you once you understand how that stuff works. And so, anyways, ammonia detox, super important. Most of the toxicity reactions that I treat in my practice, and it's probably true for you too, are directly related to genetic defects. And it's the people who are not very good at detoxifying that are getting quite sick these days because the environment is so toxic. All right, so here's another summary of what we talked about when I was showing you the test. This is from the organic acids. 2-methylhyperate, that's the marker for xylene. Orotate, that's the marker for ammonia. Glucarate, that's phase 1, phase 2. And then these 3 markers here are all for glutathione. These are the treatments, okay? Then there's 3 different scenarios here for glutathione. We talked a lot about this already. Alpha hydroxybutyrate, you can see it when it's high, right? But not so easy when it's low. And then you can have sulfate being low too. That's kind of an end result. That's the worst case scenario. Let's see here. There we go. I didn't know this until a couple of years ago. This is like so important. I can't believe I didn't know this. It's like embarrassing. But there's something called the glutathione magnesium dyad. And most of you probably never heard of this. It's like the first thing you should have learned on your first day of naturopathic college, okay? So it's a short version of this. You can read about this in literature if you want, but let me just tell you the short version. The short version of this is if you're low in magnesium and you're low in glutathione, you have a serious problem. If you're low in magnesium and low in glutathione and you take magnesium, you're not going to absorb or use the magnesium very well until you get your glutathione levels up, at which time then things work properly. So in other words, if you're low in magnesium and low in glutathione and you give magnesium, the magnesium won't be absorbed and processed very well until the glutathione comes up. So if you have a glutathione problem and a magnesium problem, right, and you try to bring up glutathione, unless you deal with magnesium, it's not going to work very well. So you have to treat these 2 together, glutathione support and magnesium support simultaneously in people that have problems with both of these things. And I wish I had known that 20 years ago that would have helped with a lot of different patients. And you're just wondering, why are they not responding very well to this, magnesium? Well, that's why. And this is a research study that shows that. If you're curious, you can look at this slide later. But basically that as your red blood cell magnesium levels drop, your glutathione gets in more and more trouble. And the reverse is true too, right? The more magnesium that you have, the better off that glutathione is processed. Okay, so let's take a look now. Oh, a couple of things on the promotional side. We have this half-off class if you're interested on neurotransmitters and mitochondria. And I get into neurotransmitter imbalances, mitochondrial function, just try to make it clinical like most of the stuff I teach. And pretty straightforward. It's a couple-hour course, maybe like 2-3 hours, something like that. Maybe it's more like 4 hours. And then we have a boot camp that we're starting now, like right now. If you guys are interested in doing some work around your business, these have been really popular courses. It's business training. It's nothing to do with clinical. So we look at financial planning, business planning, sales and marketing, kind of the nitty gritty of business planning stuff. And we're giving you guys a 20% discount on that, okay, if you want. And the course is around $1,000 US. So you get a couple $100 off if you want to start a business course. Okay, now let's look at some cases here. I think I can just back out of here. There we go. Let's start with this one. All right, now let's just look. We're going to take a minute here and just look at the entire lab and talk a little bit about reference ranges and how you're supposed to interpret the test as a whole, right? Rather than learning this piecemeal, I'm going to actually spend a fair amount of time on this because most of the questions we got after the last conference were about this kind of practical stuff. So it's clearly confusing for everybody. So now I feel like Dr. Lord. It's so funny. This is exact. I'm just saying the exact same stuff he said to me this morning. What's important about this test? Oh, it's so funny. I wish I could speak it with his accent. He's got a Georgia accent. He's from Georgia. Well, first of all, what are we measuring? We're measuring plasma. That's important. Keep your mind on that. And what's the actual thing we're measuring is lysine. Then look at the way that they're giving you some hints here. There's a 95% reference range over here. That's very, very important. And then there's quintiles, right? So you can see where on this spectrum, where on this bell curve is the particular thing. And then here, you'll see with an amino acid, if it's in the lowest quintile, we consider it low. And generally, if it's low, you want to supplement with it. That's pretty straightforward. If an amino acid is high, over the limit here, then it means it's circulating in the plasma, circulating in the bloodstream, and it's not getting into cells. It could mean that they're eating too much protein, although that's relatively rare. Most of the time it means that they're deficient in B vitamins. The B vitamins are what help us break down amino acids. Okay, so usually a pattern, not a single one, but a pattern of high amino acids means there's a B vitamin deficiency. If there's low amino acids, usually you just supplement with that amino acid. Why are the amino acids low? It can be a lot of things. It could be absorption, could be their gut's not working well, could be they're just burning through the amino acids real quick, something like that. So that's worth knowing about. And let me just go on to see. Yeah, we're gonna talk about this guy here. So now another way to look at these, you can see now they've taken all the amino acids related to the urea cycle, which we just looked at, and they've kind of grouped them together in one spot for our convenience. And remember we just saw those: arginine, citrulline, ornithine, glutamine, asparagine. Let me just show you the image again so you can see. It's the wrong one, sorry. This guy here. What we're looking at is citric acids, the urea cycle, right? Arginine, ornithine, citrulline. Now we're looking at those. So imagine this cycle as we're looking at the lab. And if this cycle's broken, there's going to be either high or low amino acids related to the cycle, and that means you cannot clear ammonia very effectively. And so now, what do you see? Well, starts off fine. This looks pretty good. Well, that looks perfect. Uh-oh, ornithine is low. Glutamine is fine. Asparagine is fine. Aspartic acid is a little high. So ornithine is low. So now we're thinking, what does that really mean? Ornithine is low. Where would there be a block if that was happening? Right here, right? So there's enough arginine, but not enough ornithine. That means there's a block with either enzyme number 5 or enzyme number 6. Now, most people are happy just to hand the patient a bottle of arginine at this point. If you're one of those like research-oriented people and you're like super smart and you're the one that would be sitting in the front wearing glasses right now, then you can look this up and you can go arginase, ornithine translocase, hyperargininemia, high arginine in the bloodstream. Again, if these enzymes are broken, ornithine is going to be low. And you can, now if you're like really into this and you want to buy a book about this, then there is a book about this. And Dr. Richard Lord wrote this book. It's called Laboratory Guides to Health. It's a couple $100. It's like I think it's $279. You can buy it from iTunes or wherever you get your iBook stuff. You have to download it to an iPad, an iPhone, or a Mac, okay? Which is inconvenient, but it's a really great book. It's $279. And if you're curious, you could type in Urea Cycle and spend, the rest of the week just reading about all the things that are related to the Urea Cycle and all the research studies that are related to what we're talking about right now. So this is a very detailed book. It's a very intense book. It's got a lot of great information in it. But if you're one of those people that really likes to see all the science behind everything, you'll love this book, right? Now, sorry, I lost myself here. Yeah, here we were. Okay, so now this patient was low in ornithine. So now hopefully you can just imagine normal, SNP, remember, genetic defect right here, low ornithine. Why is that happening? This enzyme is broken. What's an enzyme? It's a protein. Why is it broken? Because it had a bunch of amino acids in a string. There was one amino acid that was wrong. There was some alanine where there should be some arginine, and it had a slightly different polarity or charge. So when that protein folded, the enzyme doesn't work. So you can't turn citrulline into ornithine. There's a SNP, single nucleotide polymorphism, a genetic defect in this person's urea cycle or ammonia detoxification capacity. When ammonia builds up in your brain because of this kind of problem, it doesn't feel very good. People don't like it. You give either, in different cases, either arginine or citrulline or ornithine as an amino acid. It'll push along the urea cycle and the person gets better pretty quickly. Most of the time, for most of these urea cycle problems, people just give arginine. Not too many people prescribe citrulline or ornithine. You can get it from a few companies, but probably 95% of the time, people use arginine for all these problems with the urea cycle. Okay, so now you learned all about the urea cycle. That was worth knowing about. Let's see. Now, we're kind of looking at this from a markers standpoint as well. These are pretty straightforward. Either they're high or they're low. There's not a lot of mystery in that. Except for there's one mystery here, and this is pretty confusing. So I should just cover it. So if potassium, magnesium, zinc, copper, or selenium are low, you give that nutrient. If any of those are high, they're taking too much of that nutrient. You should cut them back. Calcium is the exception. Calcium on this particular test is a measure of membrane permeability. That is confusing. So if calcium levels are normal, calcium levels are high, if calcium levels are low, it has nothing to do with the calcium that's circulating in the bloodstream. It's a direct measure of membranes, and membranes allowing calcium to go in and out of a cell. It's a little confusing. So the other markers are what they seem, But you know, a low calcium marker doesn't necessarily mean the person's low in calcium. It's more reflective of the membranes. Toxic elements are what they are. The lower, the better. If they're high, it's bad. Not a lot of mystery on those. Same with these guys here. Relatively easy to measure. If they're high, it means they're supplementing too much. If they're low, it's bad. You should supplement with the CoQ10 or vitamin A, whatever it is. These markers are really confusing. So in general, high oxidative stress markers are bad. We all know that. However, can oxidative stress be too low? Absolutely yes. That's kind of an advanced concept. Can you have not enough oxidative stress? Yeah, you can. That's possible. How would that happen? Well, where does most of the oxidative stress in your body come from in the first place? From your mitochondria, production of energy. So if you have chronic fatigue and you barely get out of bed and your mitochondria are shot, you might have low oxidative stress because of low energy production, and that is bad. So it's not a lower is better kind of situation. You need a certain amount of oxidative stress just to be alive. Vitamin D is easy, right? It's just low is bad, high is bad. Oh, the fatty acids, this is complicated. In general, if they're high, they're over supplementing. If they're low, they're deficient. And you'll also see a lot of enzyme defects on fatty acid markers. I can show you some examples of that in a minute, but when you're looking at the fats, and the fats these are fats that make up all our cell membranes, so they're very important for detox. Because if the cell membranes are weak, you're going to have toxins leak in to the cell, and that's going to cause a problem. So if you see a pattern like we just saw with the urea cycle, where it's normal, normal, low, you know, then there's oftentimes a genetic defect related to the production of fatty acids. That's not the case in this example. We'll probably come across one in a minute, and I'll show you. But those are pretty straightforward. And here's something that's hard for me to wrap my mind around, but maybe you guys are ahead of me on this one. But when we look at, like, for example, saturated fats, of course they're coming from your diet, like, I don't know, butter or beef or coconut oil or whatever. But a large percentage of these saturated fats are made in your liver. That's a little strange. So when you see saturated fats like this, it's a combination of dietary factors and the liver's ability to make fat. And there's a lot of people who are not very good at making fat, and you'll see the saturated fats are low because the liver is not working very well. And that in particular is going to be related to these two, palmitic and stearic. If these are both low, it often means, not always, but often means that the liver is not making them. And that is a big problem. Isn't that strange? So it's not just about your diet. A lot of this revolves around internal production of fats. It's very important that we make enough fat. Okay, got a few more minutes here. Let's see. I think I covered all the major ones. Probably can't cover them all. But anyways, we covered, I think, the major issues in terms of interpreting these in relation to detox. So let's look at a couple of cases here and see what we would do. To see, boom, read. All right, case one. I don't know where this came from. This is an old lab. So, ouch, that doesn't look good right off the bat. All these low amino acids. Then what are you thinking? They can't make proteins. And let's look at specifically, because of the topic today, detox. So let's look specifically at their, and this is nice, they group these by category. So they group the sulfur amino acids. Why are those so important? Remember, that's phase 2 detox. They smush them all together there. Those look okay. And then the urea cycle for the clearance of ammonia. And look, right off the bat, arginine is low. There's a SNP or an enzyme defect right there. How do you know? Because citrulline, ornithine, glutamine, asparagine, and aspartic acid are all fine. How could arginine be low by itself when all those others are fine when it's in a cycle? Let's look at the picture one more time. So arginine is low. That means that there's a SNP. Wait, no, sorry, I'm drawing it in the wrong place, sorry. Hopefully one of you in there was saying, no, Dan, that's not the right place. There's a SNP right here at enzyme number 4. That enzyme is busted. Arginine is low. These other enzymes are all working. Okay? So to get the urea cycle going, get the ammonia out, you're going to give them arginine. Typically, we start around 1,000 milligrams 3 times a day. Go up from there if that's not enough, sometimes as much as 6,000 milligrams a day to get the ammonia to start to flush out. All right, let's see. And we're just looking for detox markers, so I'm going to kind of skip through portions of this. Now, magnesium is really important for detox. And so this person's low in magnesium. That's easy. Just give magnesium. There's nothing special, no trick there. Selenium is really important for heavy metal clearance, so you'd also want to give them some selenium. So magnesium and selenium. They have high cadmium. There's a toxin, so we're expecting that to drop on the next test once we've got their detox pathways working better. Fat-soluble antioxidants are low. Remember, antioxidants help with phase 1. So phase 1 detox, you want to get that working. CoQ10, vitamin E, vitamin A will get CoQ10 working, those antioxidants. And let me just show you one more time in case we talked about this a while ago, but let me show you here. The liver. Remember phase 1, antioxidants and B vitamins. And then phase 2, the sulfur amino acids. So we're just looking at all those markers now, see if a person needs to detox. Fatty acids, oh, that's interesting. So alpha-linolenic is low. That's flaxseed, right? The others all look okay. And why are those important? Because they make up the cell membrane. Cell membrane is what protects us from toxins getting into cells. Oh, we don't have time to talk about this, but I'll just point out. See this perfect V here? Look at that. Palmitic, low. That's really important, but it's not the subject of today's talk, so sorry, I'm going to have to skip it. That's like a whole another 2 hours right there. But that's important, right? If you ever see that, let's see. Mitochondria, we're not really talking about mitochondria today, but you know, we just mentioned that you do need to deal with them. B complex markers. All right, I got to talk about this because this is an interpretation thing. Then we're going to open it up for questions, okay? So that's another one of these, like, I don't really understand how to interpret this kind of questions here. Oh, this is so complicated. Let's start with the easy part. These are all B vitamin markers here. If they're high, any one of these that's high means the person is deficient in B vitamins, and that's easy, okay? If any one of these 3 is high here, that means they need B complex. Just give them a B complex. If xanthronate is high, it means they need more B6. Give them 100 or 200 milligrams of B6. And if this one is high, it means they need biotin. Give them like, I don't know, a lot of biotin. 3,000, whatever you're going to do, you know, for biotin. Now, what about when they're low? Does that mean their B vitamins are low? No. But when they're all low, is that a little suspicious? Yeah, it is. When they're all low. That makes you start to wonder, are there even enough mitochondria present to make a reaction? So high markers mean for sure they need B vitamins, you prescribe them. If they're all low, it is very suspicious. It's a question mark, like what's going on? Why are they all low? How could that even happen? Maybe there's not enough mitochondria to make a reaction. Okay, so that's something to be on the lookout for. And you can see there's a bunch of weird patterns here too. Now, detox markers on this person are all normal. And remember, if alpha hydroxybutyrate is undetected, it doesn't mean much, right? Because that range is so broad. Could be here, we just don't know. If it's high, it's bad. If it's undetected, it's meaningless. It's just, you don't know. If pyroglutamate is low or sulfate is low, that's low glutathione. If pyroglutamate is high or sulfate is high, there's also a problem with glutathione, but it's worse if they're low. Okay, it's more extreme if they're low. So now let me just summarize and see if we got most of these things covered here, and then we'll open it up for questions. We still have about 10 minutes. So we went through all of phase 1 and phase 2. You can see how that works, right? Sulfur amino acids, and, don't do phase 1 nutrients if they have a phase 2 problem. People get into trouble for that, with that. And then we talked a lot about amino acids and how important they are, not just for detox, but for protein synthesis. Why do proteins matter? Because that's how we make all our enzymes, right, that we use to detox. And then we use this as just a simple example of defective enzymes. If any of these enzymes are broken because of a SNP and the misfolding of proteins, you can't get rid of ammonia. Obviously, I didn't mention this, but hopefully, obviously, you know that there's a gazillion enzymes running this. So there's a lot of potential for genetic defects from MTHFR down, right? So just to keep that in mind. And then we talked about organic acids and how you can start to track the detox pathways there. And then here specifically on organic acids, these three being glutathione related, glucarate, phase 1, phase 2, orotate is the one related to ammonia, and then methylhyperate shows that they have high xylene, right? And and then to wrap up, one last thought. Don't forget, if you ever have a patient low in magnesium, check their glutathione. And if you ever have a patient that has a low glutathione, check their magnesium. Usually you want to use those two together. And then we have our neurotransmitter and mitochondrial class that's half off, and we have our boot camp that we're starting now. You can still get into this one. If you can't make it to this one, we'll have one in February again, I think. If you want to do business-related stuff, you can join a boot camp. And if you want to do more clinical training, you can grab one of our master classes that are half off, okay? All right, so I'm going to open it up for questions. We got about 10, 12 minutes left.
Thank you, Dr. Kalish. That was a really great practical hands-on workshop there, exploring the labs and cases from your practice, and particularly going through the meaning of those individual markers and the grouped markers. So I hope that's given your attendees a deeper understanding of that ion panel and then how to apply the results from that test in clinic, focusing on detox. So some questions, yeah, please send those in. But the first one, Dr. Kalish, do you address phase 3 detox before addressing phase 1 and 2? Do you work backwards?
What is phase 3? I forgot. I don't really do that. I read about that years ago. I blocked it out. Is that ATP production? Maybe the person can type in what it is.
Phase 3, well, it's further getting rid of the toxins, isn't it? Dr. Carrie Jones talks about phase 3.
Yeah, I ignore phase 3. I should probably pay attention to it. I read about it years ago, and then I just decided to ignore it. So I can't answer that question. I'm not sure.
Okay, do you start with phase 2 always before phase 1, so you don't get the buildup of the toxic intermediaries?
Yeah, well, this is complicated. So if they have a phase 1 and phase 2 problem, then you always start with phase 2, because the whole thing I went through, you don't want to make them worse, right? If they only have, so if they have a phase 2 problem, it's all based on labs. If they have phase 2 problem only, you start with phase 2. You don't even need to do phase 1, right? If they have a phase 1 and 2 problem, then you start with phase 2. If they have a phase 1 only problem, then you crank up phase 1, but guess what? You give them a little bit of extra support for phase 2, because if phase 2 looks great on the labs, but you crank up B vitamins and antioxidants, you're going to be pushing phase 2 harder, so you got to give phase 2 support. So I guess phase 2 support is always in the program, even when it's not on the labs, right? That's another way of saying it.
Yeah. Thank you. Would you address the urea cycle ammonia toxicity in most of your patients?
Oh, if it's on the lab, I mean, I don't see it all the time. It's maybe, I don't know, a couple times a month I see it. It's not every day, you know, but it's common. It's common, and it causes very predictable brain fog, fatigue, depression type symptoms. And yeah, it's something that, you know, if you have a busy practice, you'll see it, you know, a couple times a month at least. That's the main problem. Oh, someone just said phase 3 is the gut. Well, yeah, well, let's look at that. And I talked about that in the beginning. So like there's a treatment sequence to this, right? So you always want to get neuroendocrine systems working, fix the GI, and then do the detox once the GI tract is in place. That's the standard treatment sequence I always teach, like that. Yeah.
Great, thank you. What are the likely symptoms of phase 2 not working when you've started phase 1 detox?
Oh, if they're getting worse, oh, they'll complain. They'll be more tired. They'll have GI problems. Their skin will break out. They won't be able to sleep. Something bad will happen, like that. And it's usually pretty obvious because they'll come back and say, "I feel worse."
Can you please briefly explain the low palmitic acid? I know you said you didn't have time, but just briefly so it gives attendees a bit of an idea.
Yeah, maybe we can do this one next time. Let's see. Let me show you here. Oh my God, this is a really important thing. It's so important. It's like, and especially in this, well, you guys have a different situation, but in the United States, just about everybody's got COVID right now. And one of the things that COVID causes is, you know, happens is you get hypoxic, right? You don't get enough oxygen. And that has a really negative effect on your mitochondria, which in turn has a really negative effect on your fatty acids. Let me see if I can find one here. Just briefly, this is like a 2-hour talk in and of itself, but I'm going to show you, let me just show you reference ranges. So at least you can start to think about it. So remember the reference range, 95% reference range. Look at the ones that you guys are familiar with, like EPA, you see that there? What's the reference range? 5 to 200. And that's micromoles per liter. Or another famous one, DHA, the DHA is good for your brain. It's around 30 to 200, right? That's the amount of the fat that's healthy for you. Now, if we look at palmitic, remember we just looked at numbers that was around 5 or 30, and look at the amount of palmitic that your body has. 600 to 2,000 units. It's like 2 orders of magnitude greater. It's a massive amount of this compared to something like the essential fatty acids that we think of being so important. So this is the dominant fat in the body. You can see just by output, right? And so if this is happening here, you're getting enough capric, lauric, myristic. There's a genetic defect right there, right? And that palmitic, and it's not dietary. You couldn't have a dietary genetic defect, right? This is related to the internal production of palmitic in your liver. So that's a liver problem. That's a problem with your liver not being able to make palmitic. Remember I said a while ago that it's weird because the saturated fats are a combination of what we eat and what we produce. And palmitic is primarily being produced in your liver by your liver endogenously. And there's a certain extent to which it's impacted by your diet, but primarily your liver is making this stuff. And that's the most central and important fat. Is just look at it by volume. So if it's low, the total volume of healthy fat in the cell membranes and for energy production, all that's going to be low. But you know what you know what you can get palmitic, coconut oil is palmitic, you know? You don't even have to use a supplement, just have them start to consume coconut oil.
And there's been comments floating around that you can take too much coconut oil now. What are your thoughts on that?
Absolutely, I see that all the time. Oh, Americans are crazy. Like, I really am going to move to New Zealand one of these days. I told Adam if he gets me a visa or green card, I'm out of here. Yeah, Americans just do crazy things. You know, they learn about coconut oil and like, oh, coconut oil is really good for you. So then they start putting it everywhere, you know, on everything. And yeah, it's totally excessive. So you'll see if they're consuming too much coconut oil, lauric will go high. Palmitic usually doesn't go high first, right? Because there's so much of it anyways, but you'll see high lauric with the people that are over consuming coconut oil. I see that all the time.
Okay. Thank you. Next one, Dr. Kalish, can you please explain the creatinine reading on the ion panel
Oh yeah,
and what that means?
I should have done that. I'm glad whoever asked that question. So on all the organic acids tests and on the ion panel also, both, right? At the very bottom, the very end of the very last page is the most important marker. Do they tell you this? No. Does it have like a big red flag? No. It's just stuck there in the margin at the bottom of the very last page. See? And you see it there? And they don't even make it in bold. So it's called creatinine. So creatinine is the number of creatinine, in this case 200, is the number in which everything else is divided into. So what does that mean? It means that when you run this test, you're like this science person, you're sitting at this LCMS machine, and you're watching these spikes come off, and they have numbers with them. And then you take that number from the D-lactate or tricarballate or whatever, any of these markers, and you divide it into creatinine to get the final number that you put on the person's report. So now if you go back to fractions, and you know, my son is graduating in a few months from university with a dual degree in mathematics and physics and a minor in computer science. I'm very proud of him. And he is going to go on and study mitochondrial growth rates in graduate school. However, my math skills ended, you know, in high school. I'm not very good at math, but I remember fractions. So we remember in fractions, if the bottom number is small, like 1/10, the fraction is big. If the bottom number is really big, the fraction is small. So creatinine is in the bottom. So let's say that your machine spits out a number like 20, and then your creatinine is 200. That's going to yield what they actually put on the report because they're dividing each of the numbers into creatinine, right? Now, what if your creatinine then was a 20? Would that be a bigger number or a smaller number? It'd be a lot bigger of a number, wouldn't it? It'd be a 1. So if creatinine gets really small, the numbers on these reports get over-reported. They'll go falsely high. Okay. So if your creatinine on a patient's test is 20, none of these markers are accurate. I hate to say that. They're all going to be reported a little too high. And the rule of thumb is if the creatinine is below a 50, if it's lower than a 50, then every number on here is going to be reported slightly high because of the whole fraction thing I just went to. So you just simply want to adjust each marker down 1 quintile. So like this one would come down to here. This one would be even lower than it is already. Depending on which marker it is, this can be good or bad, right, as it moves around like that. However, I got to add one more thing to that. So again, if creatinine is below a 50, you want to move every marker down 1 quintile because it's over-reported. It's a little too, you know, the computer's going to spit out a number that's a little too high. However, some of these numbers you'll see get reported as highs. Let me show you. They don't have one in here. I'll just have to draw it because we're running out of time. But let's say that there's a red H here, a red H, and this number is quite high. Even after the creatinine adjustment, it's still going to be high. So if there's a red H by it, it'll stay high. If not, and it's just in the upper quintile, it's going to drop down into the normal range. That's the general rule. And why would creatinine be low? Either because the human being is small, that could be a child who does not have a lot of muscle mass, or it could be someone like my mother, who's like barely 5 feet tall and doesn't have a lot of muscle on her because she's 83. So it can be normal to have low creatinine. It just means there's low muscle mass. Doesn't mean anything's wrong with that person. It could be a 10-year-old kid or 83-year-old woman, but you need to make that adjustment to get accurate feedback on the test.
Great, thank you. Dr. Kalish, we might just have time for one more. There are a couple of other markers for Clostridia that appear on another test, for cresol and HPHPA. Do you have any comment on those? I know they're not in this test. Is the marker in this test sufficient enough to detect Clostridia?
Oh, that's a complicated question. So there's like 600 different kinds of Clostridia organisms. Some of them are good, and there's one, a very famous one that's bad called Clostridium difficile. And so organic acids are one way of looking at intestinal bacteria, but you always want to correlate it with a microbiome test, with an actual stool test. And there's some of the Clostridia that are quite good. Again, there's like 600 good ones, and then there are a few that are bad. So it's, depends on which one it is.
So if that marker came up high, you'd want to confirm with a stool analysis.
Always, yeah.
Yeah. Great, thank you. So that brings us to the close. We better finish up there, but if there's any more questions and that we didn't get to, I'll send them through to Dr. Kalish and then forward you the answers. So thank you so much, Dr. Kalish, for that really informative webinar. I think it was great and very practical going through those lab reports and having you explain the reference ranges and so on. So I hope that's given the attendees a deeper understanding of that report. Now, just to mention our specials, we are offering discounts on tests and relevant products still. So many that Dr. Kalish has referred to today. So the specials order form will be emailed to you along with the recording of today's webinar. So if you didn't feel you caught every explanation there, you can re-listen. So please take advantage of the specials. And also just to remind you, and Dr. Kalish mentioned his excellent online educational courses. So this is the Business Essentials Bootcamp, and it's a fast-paced deep dive on all aspects of running a profitable functional medicine practice. So please take advantage of that. And there's a 20% discount for all the attendees listening today. So that concludes our session. I'd like to take this opportunity again to thank Dr. Kalish for sharing all that knowledge and giving us insight in clinical pearls into the organic acid testing. And I hope that the attendees have gained a better understanding as well. So please do not hesitate to contact us at NutriSearch for any queries you might have in the future on this test and products relevant. I'm available to assist practitioners interpret their patients' test reports if needed. So from us all at NutriSearch, thank you very much again for listening today. That's the end of our Part 2 webinar series, and we'll hopefully have Dr. Kalish some stage again next year. And yeah, hopefully in person would be even better, but we'll have to see how the COVID thing goes from here on in. But thank you very much and have a fantastic weekend. And thank you, Dr. Kalish.
Bye now.